Thank you, Mustafa. I am elated today to welcome Dr. Muhammad Ali sir, who needs no formal introduction. By now, every one of us have become very familiar with such an eminent personality. So I now request you, sir, to start with the topic understanding of basic research. Over to you, sir.
हे केलं नाही का? हे केलं फक्त आता डिसेबल केलं तर Good afternoon, my friends. I take this opportunity to share some few experiences. Yesterday, I had already spoken regarding the research errors and the review of literature as to how it is to be carried out. And today, as it says, the basics of research. And in terms of the basics of research, am I audible, Suleiman? Hello, am I audible?
Yes, sir, you are audible.
Yes, sir, you are audible.
Okay. So, as we had spoken about the errors and the review of literature, maybe in today, as we have the theme, basics of research, I would like to draw your attention towards the yesterday's discussion that in terms of the data processing error, what I had spoken about, regarding this data processing error, we should just take it forward in order to make it more understandable and to minimize the errors in the data processing. Why am I emphasizing on this issue is because that we come across 99% of the scholars who collect the data, but unfortunately, they are not in a position to understand as to what statistical tools should be exactly used in this regard. So therefore, today, our focus of discussion would be on the data what you have collected, how do you process the data, with what basic statistical tools, that will be discussed. And of course, we have an expert on this, rather than me, Dr. Sattikar sir, who happens to be my colleague at VP Institute, who has put in almost 18 years of his service, and he has completed his MPhil and PhD at the Shivaji University, Kolhapur. And I am proud to tell you that he, being an IQAC coordinator and belonging to the computer department, he has devised the softwares for our library as well as to the office in terms of the in-house softwares have been developed by Dr. Sattikar. This is one of the proud instance for us while introducing Dr. Sattikar sir. He has published more than 50 research papers and articles in various journals, magazines, and similarly, as it's the Shivaji University has a competition, a research competition nomenclatured as Avishkar. So in this Avishkar, he made a presentation and he has secured the second position in terms of this Avishkar. This is the brief description about Dr. Sattikar, who would be taking over the charge and then explaining you as to in terms of the data processing, the minimization of the errors with the help of the statistical tools which is at your disposal, whereby the basics, the crux of the basics of research would be taken care of. So I request Dr. Sattikar sir to take over the charge. Sattikar sir, please.
Entire organizing team, Dr. M.M. Ali sir, and all the participants. A very good afternoon to you. First of all, I'm very much thankful to organizing team for giving me this opportunity to share my views on this particular data analysis techniques. And especially, I'm very much thankful for Dr. M.M. Ali sir for providing me this opportunity, finding me suitable for delivering my speech. I will not call it as a speech, so I will just share my experiences. So what problems I faced during the data analysis phase, what different things we have to consider during this data analysis phase. So this will not be a lecture type session, but I will just share my experiences. I will give some tips. I will try to give some tips how data analysis phase should be carried. So let me share my screen. So my screen is visible and am I audible?
Yes, sir, your screen is visible.
So the basic of research. Yesterday, Dr. Ali sir talked about what general mistakes researcher can do in some earlier phases, and now it is most important before we go for data analysis, what care we should take. So every one of us is knowing the research process, where it starts and where it ends. So initially we have to identify a problem. We can consider it as a research topic. Then we have to define objectives related with that topic. Then we have to formulate hypothesis. Then sampling design, another important aspect. Then data collection, data analysis and hypothesis testing, findings, suggestions, and then we will prepare the research report. So normally what happens when we study research methodology or when we study these research processes, generally we study them in an individual manner. So we concentrate each and every process individually. But before you go for data analysis, it is very important to understand that all these steps in research process, they are interrelated, and finally they are going to have an impact on your data analysis. And yes, obviously data analysis phase is very important because the quality of research, it depends upon the data analysis, what interpretations, what inferences we have drawn from our data. So that is very important, and that's why it is very important to identify, to know that all the earlier steps, they are depending, they are related with each other, and they are going to have a huge impact on your data analysis. So generally when we talk about data analysis, there are two types of analysis. One is a descriptive analysis and another one is inferential analysis. In subsequent slides I'm going to describe them in detail, but generally we know descriptive analysis, it is an analysis related with individual variable, where we find some mean, mode, standard deviation things on individual variable. And yes, inferential analysis, it is related with the hypothesis testing. So most of the time, inferential analysis, it is related with the hypothesis, but it is not necessary, because by using some inferential analysis, we can have some objectives to get achieved. So generally consider that inferential analysis is very useful when you are going to satisfy your objectives and when you are going to test your hypothesis. And generally, what is mean by inference? So generally we collect the data from sample, we analyze our sample data, and then we try to relate it with population. So as we know, every time it is not possible to go and study entire population. So normally we select some sample, we select some sample size, then we carry out the research based on that sample, and then whatever the results we have drawn, we try to relate it with the population. So that is somewhat inference, that is somewhat inferential analysis. But again, if we go into the more details, there comes the analysis like one sample, two dependent sample, two independent sample. So such things are going to be involved in that inferential analysis. And these things are not any different things, but they are related with what sample we have chosen. So initially, it is very important to know what is descriptive analysis. It is analysis of individual variable, inferential analysis, some statistical tools, some statistical tests that we apply to satisfy our objectives or to test hypothesis. Again, there are concepts like parametric, non-parametric, which we will discuss in later stages. Okay, and another important thing here, we should understand what is the relationship between this descriptive analysis and inferential analysis. Can we straight away go for inferential analysis? No. Unless and until we are having descriptive analysis, we cannot go for inferential analysis, because in inferential analysis, we are going to find some relationship between variables. Suppose I am having a one sample data where I am comparing weights. Weights, suppose for example, weight of male respondents and weight of female respondents. So what can be the comparison? I can compare the mean of those weights. I can compare variance of that particular weights. So in comparison, you need that descriptive analysis. So unless and until I know how to calculate mean, mode, median, variance, standard deviation, I cannot go for inferential analysis. So it is very important to know that the descriptive analysis is the base of inferential analysis. Now, when we are going for data analysis phase, and when the quality of entire research, it depends upon the quality of data analysis we are having. So it is again important to know that the quality of data analysis is depends upon the quality of data which we have collected. So if your data is reliable, if your data is adequate, if your data is suitable, then obviously what qualities we expect in our data analysis, those are going to be there. So when I'm saying the data is reliable, what it means, I should collect it from reliable source. So we know there are two sources. One is a primary source, secondary source. So what source you have opted for? So whether you have collected data from primary source or secondary source, or it is a mixture of both. So it is going to decide the reliability, how much I can rely upon my data, so that what qualities I can find in data analysis phase. When I'm saying data should be adequate, I'm relating it with the sample size. So I'm studying a one topic in which the population size is 10 lakh. And suppose if I'm only selecting 1000 respondents as a sample, whether it is adequate, whether it is enough. Okay, so that is adequacy of data, the amount of data which you have collected, whether it is adequate. And the third most important thing, whether data is suitable. And the suitability, it is obviously related with objectives and hypotheses. So based on the data which you have collected, whether you are going to fulfill the objectives and whether you can test the hypothesis. Whether I am having all the data with me so that my all objectives can get satisfied and all the hypotheses can be tested. So as I earlier said, we know the research process, we know each and every individual step in that, but now it is very essential to understand the interrelationship between them. So what objectives you have set, what hypothesis you have set, what is your sample size, what source you have selected, it is going to decide the quality of your data, and the quality of your data is going to decide the quality of data analysis and overall quality of your research. Now, most of the time when we start learning this statistical techniques for data analysis, what is the problem? If you go through different books, for each and every test, some different examples are given. So ultimately, we cannot correlate it with our research, because we are going to apply these tools, these techniques on our research, on our data. So maybe for one test, I will get some different example in book. For another test, I will get different examples. So generally, when you will start studying this data analysis and when you are going to study some different techniques, because what I find most of the time researchers feel that statistics is very complicated thing. And that's why data analysis is the most complicated part of research. Okay, because so many formulas are there in different tests, even though some ready-made tools are available like SPSS, Excel. So how to code the data in SPSS, how to code the data in Excel, how to select proper test, it is very difficult. So data analysis and especially studying these particular tests is very complicated part, but it is not the case. So I always give an example to my students that if you know addition, subtraction, multiplication, division, you can understand each and every test. Only important thing, we should understand the applicability of that particular test. Because if you study the statistical test tools which we are going to use for hypothesis testing, there are more than 30 different statistical tests. So all tests are not applicable to my research. So applicability is the important thing. Okay, and if you want to study these statistical tests, try to create one example and try to apply all the tests to that particular example. Don't study different examples for different tests. Okay, so that's why first identify some simple problem, one simple problem. So here I have given one example, a study of employees opted for VRS with special reference to Sangli districts. Then I'm having certain objectives to evaluate employees' intention towards VRS, voluntary retirement scheme, and to investigate employees' satisfaction level after VRS. So just consider one simple example, try to convert it into a research problem, try to set some objectives and try to set some hypothesis. So here is the hypothesis. Now again, obviously you have to study these steps in detail. So how to set objectives? What are the good characteristics of objectives? Then what is hypothesis? What is null hypothesis? What is alternate hypothesis? So that part is there in my later slides. So just try to set some hypothesis. So as in my example, I have tried to set one hypothesis. There is no significant difference between age of retirement of satisfied and dissatisfied employees. So I have considered that after taking VRS, some employees are satisfied, some employees are dissatisfied. So I want to compare whether there is any relationship, because maybe dissatisfied employees may have gone earlier for VRS and satisfied employees, they may have gone after some years. Means generally we consider 55 as a voluntary retirement age. So maybe dissatisfied employees have gone for 45, 50, and satisfied employees, they have gone for retirement which is very closer to 55. Just example. So I want to find whether such significant difference between the age of retirement of satisfied and dissatisfied employees. There is another hypothesis. There is no significant relationship between post and satisfaction of employees opted for VRS. So I have considered the data of employees which retired from the different posts like clerical post, managerial post, executive post, and their satisfaction level, whether they are satisfied or dissatisfied. So this is just example. So we must have problem with us, research topic, then we must have objectives, then we should set hypothesis, and now we have to identify the source of data, because earlier I have told you that all these things are going to matter a lot. They are going to contribute in the quality of data which you are going to collect. So primary data, secondary data source is there. Now another important thing is the sampling technique, because we have discussed that data should be adequate. It should get collected from adequate amount of respondents. So how I'm going to select that respondents? What will be my sample size? And more importantly, what will be my sampling method? So we all know two sampling methods are there: probability sampling, non-probability sampling, then in probability simple random. Now, what is the significance of this sampling method on our data analysis? How sampling method, what sampling method we have chosen, how it is going to have an impact on my data analysis? Because when we are going to apply some tests, the test assumes some things about our data. It assumes something about our sampling method. For example, t-test, it assumes that you have collected your sample randomly. You have opted for simple random technique, because it says your sample should be randomly selected from normally distributed population. So it is very important. We should identify what hypothesis we have set, what objectives we have set, what test we are going to apply, and according to the test, whether we have applied sampling method or not, or you can go vice versa. Based on your sampling method, you should go for the test. Okay, I have not collected my sample randomly, So now t-test is not applicable to me, so which test is suitable? So that's why this interrelation is very important. So how objectives are going to have an impact, hypothesis, sample size, how they are going to have an impact on your data analysis, and ultimately the phase which you are going to carry out on inferential analysis. So after that, we will prepare some questionnaire over here. Now the example which I have considered for volunteer retirement scheme, depending upon the objectives, depending upon the hypothesis, I have set some questions. So you have to decide the suitability of this particular question, whether they are suitable to satisfy my objectives, to test hypothesis, whether all that data is covered in my questionnaire or not. That is another important aspect you should take care. So my first question is related with what was the level of your post at the time of VRS? What reason attracted you most to go for VRS? How many years did you work with the company? What was the VRS package you got from the company? Are you satisfied? Because I'm going to compare satisfaction level and the post from which the employee retired. And finally, what was your age at the time of VRS? So generally, when we think of questionnaire, we frame a question and we provide some options for the answers. So that question we call it as a close-ended question. And normally, if you look at the questionnaires, most of the questionnaire they are having a close-ended question. Now remember, this is also having one significant impact on the test which you are going to apply. Okay, so here there is a one question, what was your age at the time of VRS? And here I have not given any option. So what I expect, so respondent should enter individual values. I have not provided any option because like other questions, I can also provide some options over there. Below 50, 50 to 55, 55 to 60 likewise. And employee is going to select one of the options from that. Now it is going to have a very huge impact on the test. It is going to have the huge impact on data analysis because you are going to change the scale of that particular variable. So when employee will enter individual values, they are going to be a quantitative. And then I can go for mean, mode, median likewise. But if I provide such options below 50, 50 to 55, then totally I'm changing the scales from quantitative, I'm going to convert it into a qualitative because the words like below, above are there. Things will be okay when you are knowing the range, when you are knowing the minimum value that can be there. So if you are able to provide like this 50 to 55, 55 to 60 likewise, means you are having, you are knowing minimum value, you are knowing maximum value, then also you can calculate the mean. So how to calculate mean for individual frequencies and how to calculate them in a group frequency, that is there. But it is very important that each and every group should have some minimum value and maximum value. There should not be the words like less than, greater than, because you are totally changing the scale of that particular variable. So what is the scale of that particular variable? So after questionnaire, I will prepare the data from respondents. I will put them in a tabulation. And remember one thing, nowadays, Excel, SPSS, you can have your data tabulated in such manner. So this is data collection. This is the tabulation form of the data which I have collected. These are the responses given by some 20 employees. So my sample size is 20 and I got this particular data from those 20 respondents. Now when I will start the data analysis phase, first I will go for descriptive analysis because we know that the descriptive analysis is the base for my inferential analysis. Where in inferential analysis, I'm going to test my hypothesis, I'm going to satisfy some of the objectives, and we know that in inferential analysis, we will apply some tests. So if descriptive analysis, it is related with individual variable, analysis of individual variable, inferential analysis is normally to test the relationship between different groups in your sample. Like I'm comparing age of satisfied employees and non-satisfied employees. So age is one variable, satisfaction is another variable, and I'm trying to find some kind of association between them, either to fulfill my objectives or either to satisfy some hypothesis or test some hypothesis. So first we should know what is descriptive analysis. So descriptive analysis, as I said, you can consider it as a post-mortem of individual variable. What is the mean of it? What is the median of it? Mode, standard deviation, variance. Now, why these calculations are required? As we have discussed earlier, it is the base of inferential analysis. So maybe I will compare median of two different groups, mean of two different groups, variance of two different groups. So before I compare the variance or mean of two different groups, I should able to calculate that particular thing. So here is just one simple example. Suppose I am having a data of 20 respondents related with the weight. So how to calculate mean? Sum of all the responses divided by total of responses, mode, the most repeated frequency. And yes, before we calculate the median, we have to arrange our data in sorted order, either ascending or descending. And then we should try to find the middle value. And the middle value, it depends whether we are having number of observations odd or even. That is another important aspect. So here I am not going to teach you how to calculate mean, mode, median. But whatever the data you have collected, whatever the variables you are having in your data, some data you should go with descriptive analysis. Mean, mode, median. So here, after arranging my data in ascending order and after considering the number of observations 20, so what will be the middle value? 10th observation and 11th observation. So I will take mean of that. So luckily both the observations are 29. So here I got mean 28.75, mode 29, most repeated values, and median 29. Then we should go for dispersion, variance and standard deviation. So now we know what is variance, what is standard deviation. So how each and individual observation is dispersed from the mean value. So as 28.75 is my mean value, so I will check individual observation, what is the difference between that observation and my mean, and obviously I will take square of that. And after adding those squares by dividing with total number of observations, I will get the variance. Square root of variance, it will be a standard deviation. So in descriptive analysis, we should be able to calculate these particular factors on variables: mean, mode, median, variance, standard deviation, because later these calculations we are going to use in a inferential analysis. Some tests they compare mean, like T test, Z test. Some tests they compare variance, F test. In ANOVA also, it will compare means, variance of different groups. Okay, so this is the base of inferential analysis. Okay, and then tools like SPSS, Excel, they will ready-made provide you that particular data, descriptive statistics, by applying some formula or by applying some options. Now here, whatever the data I have collected, I can calculate mean, mode, median, variance, standard deviation of this age variable. Now remember, what is data? Data is a collection of different variables. So whatever the data I have collected so that it will satisfy my objectives, it will help me to test my hypothesis. So all that variables I have included in my question, I have collected the data, I have tabulated it. So my variables are post, reason, years, package, satisfaction, and age. So I can call them as variables. Now I can calculate all those things, all the descriptive analysis on this age variable. Why? Because this is quantitative in nature. Now suppose if we try to calculate it for post, whether it is possible to calculate mean, standard deviation, variance of this post, obviously not, because it is a qualitative data. Okay, so okay, I cannot calculate mean, I cannot calculate standard deviation, I cannot calculate variance, but what I can calculate from that descriptive analysis? Obviously, I can go for mode. What is the most repeated post, whether it is a clerical, managerial, executive? So now it is very important what kind of descriptive analysis you can have on your variable. And that descriptive analysis will be depending upon the nature of that variable, and normally we think the variable is either quantitative or qualitative, but in case of research it is considered as a scale of variable. And normally if my variable is of qualitative in nature, generally I will call it as a nominal scale. My qualitative data, it can be also of ordinal scale, and most of the time our quantitative variables, quantitative data, it can be of interval and ratio scale. Okay, so in my example here there are different variables. Now if we consider post as it is qualitative in nature, I can consider it as a nominal. The reason I can consider it as a nominal, individual values are there. There is no relationship between the value given by first respondents and the value of second respondent. Because when we talk about these scales, why nominal, why ordinal, interval, ratio, means simply we can put the things like that. If we compare two observations, now what comparison, what kind of comparison you can have between them? So reason selected by first respondent and reason selected by second respondent, there cannot be any comparison. They are individual values. They are qualitative values. So nominal. But now if you look at the post, we can consider it as an ordinal. Because normally in management, we know organization, low level management, middle level management, top level management. So some level, some hierarchy is there. So obviously managerial post is having some higher order than clerical post. Executive post is having some higher order. So here through this particular variable, through the comparison of two values, I can only compare, yes, managerial post is higher than clerical. But with what amount, I cannot predict it. Means it will not be the case that the salary of managers is double than clerical. So when you are comparing post, only order is significant. Yes, managerial post is somewhat higher than clerical post. And most of the time we find this ordinal scale in Likert type questions, Likert scale type questions. Highly satisfied, satisfied, neutral, dissatisfied, highly dissatisfied. So if you look at the values, suppose one employee has given highly satisfied and another one has given the satisfied. So obviously what we can understand, the order. Highly dissatisfied, satisfied answer is having some higher order than satisfied. And most of the time we assign some numbers to them. So here I can do like this. One will be for clerical post, two will be for managerial, three will be executive. Now first employee having value 1 for clerical, and second employee is having value 2 for manager. So it is not the case that manager is exactly double than clerical. So we should not compare them like that. Only order is significant. So such scales, normally they are called as a ordinal scales. And then what is that interval and ratio scale? So normally it is applicable to quantitative data. And it is said that in ratio scale, 0 is absolute 0. And most of the time, we find it very difficult to interpret it. What is meant by that? So 0 is absolute 0. Okay, and when that 0 will get importance, when 0 can become superior, when we will be having some negative values in our data. Okay, because 0 is obviously greater than those negative values. Means it is considered that the particular variable can be of interval scale if you are going to have some negative values in that. And then you just compare those two values according to the difference. So suppose a temperature of one city is -2 and temperature of another city is 8. So only I can compare them that the difference between the two cities, the difference between temperature of two cities is 10 degree, -2 and 8. But I cannot compare them as a ratio, exactly double, exactly triple. That I can do in a ratio scale. Because in ratio there will not be some negative values, only positive values will be there. But most of the time the tools like SPSS, they will ask you whether your variable is interval or ratio. They have SPSS will not give you separate thing. So what scale SPSS asks? Whether your variable is nominal, whether it is ordinal, or whether it is of scale, means interval and ratio. And this is very important in data analysis, because what kind of test is applicable, is suitable for my data, it depends upon the scale of variable. Because in inferential, later we are going to understand there are two types of tests: parametric, non-parametric. So whether I can apply parametric test for the variables which are of nominal scale, which are of ordinal scale, whether I can apply non-parametric test for the variables which are of interval and ratio scale, that is very important. So collecting data is not sufficient. Collecting data and identifying the scale of each and every variable is very important. And now suppose if you want one variable to be of interval ratio scale, and if you provide some options in your questions like less than 5 lakhs, more than 15 lakhs, now that variable, though you are considering amount, it will not be of a interval ratio scale. So here package, I can consider it of ordinal scale, because less than 5, 5 to 10, it is some order. If I ask individual values over there, what was a package? First employee can answer 3.4. Second employee can answer 6 lakh. If I collect individual values, then definitely my variable is going to be in interval and ratio scale. So we should identify, we should understand that every time there is no need to provide the options, close-ended questionnaire. Sometime it is better to provide open-ended question, at least for this individual. Because if you go on YouTube and if you try to learn some statistical test through SPSS, most of the time you will find the example will enter the values individually. At least the tests which are applicable on this particular interval and ratio scale, they will not provide you some close-ended questions. They directly put open-ended values, individual values over there. So now it depends. That's why I'm saying applicability. What objectives you are going to satisfy, what hypothesis you are going to test, what data is required for that, what variables you require in that, and then what should be the scale of that variable. Depending upon that, you will decide whether to ask that question in open-ended manner or in close-ended manner, because that will decide the scale of your variable. So it is very important. And now, after having this descriptive analysis, so what we can apply, suppose my variable is of nominal scale, what descriptive analysis I can have? I can have only mode, most repeated value. If my variable is of ordinal scale, what descriptive analysis I can have on it? I can have median and mode. What is the middle observation? Whether it is of clerical post, whether it is of managerial. Yes, obviously, if I consider post as an ordinal scale variable. And now, if your variable is of interval and ratio scale, you can go for all kind of calculations. You can calculate mean, you can calculate mode, median, standard deviation, variance, each and everything you can calculate on your data. So once you are having a data, once you are having identification of all the variables, identification of all the scales of variables, having a descriptive analysis ready with you, now it is time to go for this inferential analysis, which is the most complicated part every researcher thinks. But remember, it is very interesting. It is very simple. As I said, if you know addition, multiplication, subtraction, division, you can have each and every test in your research. Obviously, if it is applicable. Because nowadays, most of the research scholars, they go for some ready-made tools like Excel, SPSS. Remember one thing, these tools are for the people who are knowing statistics very well. So I know how to calculate the t-test, how to calculate chi-square test, but I do not want to waste my time in calculating the things on paper because the number of respondents are more. I have taken example where there are 20 respondents, but normally the research is having more than 200, 300. So if I decide to go for the calculations on paper, it is very time consuming. And that's why I will go for SPSS. But when I will apply t-test through SPSS, it is very essential that I should be able to calculate it manually on paper. So particularly, personally, I think that these tools are for the statisticians who are knowing the calculation. Now we are in a phase where we are going to learn these particular tests. So I'm making these statements by considering some research scholars who are doing their research. So I know the participants are of different types. Some research guides are also there. Some research scholars are there. So if you decide to calculate the particular data, if you decide to go for manual test, then don't go for SPSS Excel right now. Just try to learn these techniques on your own. That's why I have said, just create one simple example. Just set some objectives for that. Just set some hypotheses for that. Just try to prepare small questionnaire. Just try to identify scale of variables and then which test can be applied for this particular data, so that you can learn the things very well in that. So inferential analysis, and as I said, most of the time we are going to apply it for hypothesis testing. We are going to apply to find the relationship between different groups, different entities in our sample. So as in my example, comparison of age of satisfied, dissatisfied employee, comparison of post and satisfaction level. Okay, and in inferential analysis, there are two types of test: parametric test, non-parametric test. So what is exactly mean by that parametric test and non-parametric test? What is the exact difference? Okay, so generally now we know there are three types of variables, three types of scales: nominal, ordinal, interval, and ratio scale. So for each and every scale, you cannot go for parametric test. So simply consider that for nominal, you have to go for non-parametric. For interval ratio, you can have parametric, you can have non-parametric, but based on some assumptions. So generally, for parametric test, one basic assumption is that the population from which you have drawn the sample is normally distributed. And why this assumption is very significant, that we come to know in a later slides. Okay, if your sample data is not from normally distributed population, you should go for non-parametric test. So there are certain differences when to go with parametric, when to go with non-parametric. And now most of the time we should select the test based on some assumption. Suppose you want to go for a t-test, for example. So you should mention that by assuming the population, it is a normally distributed, we have gone for t-test, we have gone for parametric test. Because normally what I find, when the synopsis is prepared, when the research proposal is prepared by research students, Directly they mention we are going to apply chi-square test, we are going to apply t-test without assuming anything. So better way, when you are going to decide which statistical test you are going to apply, just mention that basic assumption and just mention the scale. As the scale of this particular variable is nominal scale, we will apply non-parametric test. After assuming that our population will be normally distributed and the scale of our variable, interval and ratio, we will apply t-test. So just try to avoid by directly saying we will go for t-test. Yes, because synopsis, definitely we are preparing it in an earlier stage. We are not knowing the exact interrelationship, all those things. So we should try to avoid such particular things. So inferential analysis, whether to go with parametric and non-parametric, it depends upon certain assumption. It depends upon the scale of your variable. And now another important part. So it is not just the scale of variable. Now one sample, two sample, k sample, plus whether they are depending, independent, that also comes over there. Now, generally the confusion is we have collected the data from one sample, means same sample. We are not having two samples, we are not having k samples. So what is this? Two dependent samples, two independent samples. So we are having a one sample, we are having questionnaire, we have asked certain questions to them, we have collected the data. So data which we have collected is from a same sample. So where there are two samples, k samples, plus dependent, independent. Because these facts are there when you will adopt test. So whether it is one sample, two dependent sample, two independent samples. So I have put one hypothesis. There is a relationship between the age and satisfaction level of employees. I want to compare age of satisfied employees and age of dissatisfied employees. Obviously, mean average age. So what I should consider it, whether I should consider it as a one sample, two dependent samples, two independent samples, k dependent samples. So I will consider it as a two independent samples. Remember, I am having only one sample, but why two? Because in my questionnaire, there is a one question, satisfaction, yes, no. So I can separate two groups from one sample. I can put yes employees in the one group, I can put no employees in another group, and then I will calculate average age of yes employees, average age of no employees. So here it converts it into two independent samples. Obviously, yes, depending on the no. So then what is true dependent? So most of the time you find the questions like before, after. So same respondents, they are giving answers twice. One for before, another one for after. So let's say I have asked one question, how much time now you spend with your family after VRS and what was the time before VRS? So here there are two questions now. Time spent before VRS, time spent after. So same respondents are going to give answers twice. So that is dependent. So such minor things we have to consider, because obviously we are not having multiple samples. We have considering, or we will consider our sample as a one sample itself, but we can make a groups, and we can make groups on some variables. So as satisfaction was having only two answers, yes, no, two dependent or two independent. But if you consider post, if I decide to make a groups based on the post, there can be a one group of clerical post, there can be a group of managerial post, there can be a group of executive post. So if you look at this particular data, if I decide to go with the groups based on the answers given in post, so there will be a one group of clerical post, managerial. Now it is k samples. So two samples means two groups, k samples means k groups, and then you want to compare certain things between that particular groups. So which test you will go for? Parametric, non-parametric, depending upon the scale, depending upon the samples, group in samples. So I consider like this. What is meant by dependent samples? Answer for multiple related questions. Yes, before, after. Answer for multiple related questions by same respondents. Having obviously some groups. So that is depending sample. Independent samples answer for single question by different groups. So managers, they are giving answers for age. Clerks, they are giving answers for age. Executive, they are giving answers for age. So answer for a single question by different groups in respondents. That you can consider it as a independent sample. So if you going to read the things from book, you will find them so complicated. And that's why the quality of data analysis, it depends how we learn the things, how we interpret them. And obviously the guides are always there. So by doing this, we can avoid the mistakes which we can perform in data analysis, so that we can select appropriate test, parametric, non-parametric, because at the end applicability is most important thing. Now just one example. What is actually this inferential analysis? What actually we are going to compare? What relationship we are going to find? So here my basic assumption is that, is there any evidence that the average age of this volunteer retired employees is 55? I got one standard data where it was mentioned that on an average at the age of 55, employees take volunteer retirement. So now this is the assumption for entire population. I don't know how many employees have taken volunteer retirement in Sangli districts. I have selected sample, only 20 employees. And remember, adequacy is important. So by considering data collected from 20 employees and the inferences drawn through it, they will be applicable to population. So now what I have decided, so I will check whether the average age given by my respondents is 55. So here actually what you are doing, you are comparing sample mean with some hypothesized value, with some population mean. Okay, so this can be one hypothesis. This can be one assumption in your research. Now we want to prove it. So we are having hypothesis. We have collected the data. Now we are going to have analysis. So obviously now what is required? Descriptive analysis. For age, first you have to calculate the mean. We have to calculate the mean for it. And then that mean we are going to compare it with 55. So here my hypothesis will be like this. H0, which normally we consider it as a null hypothesis, mu is exactly equals to x bar. Now what is this mu? The mu is called as the population mean, the value which we have mentioned over there. 55 is my population mean, is the standard mean which I consider. Whether it is equal to the sample mean, the average age in your sample, x bar. So normally, when we set hypothesis, we should set null hypothesis and alternate hypothesis. Only alternate hypothesis will not do the things. Why? Because each and every test, it indicates whether your null hypothesis is going to be accepted or rejected. Because normally it considers your sample data is exactly equals to the population data. Let it be mean, let it be median, let it be variance, anything. So the population mean is equal to the sample mean. This I will call it as a null, means the difference between both is null. That's why when you set hypothesis, null hypothesis, there should be the words like not dependent, there is no relationship. Okay, so such words should be there, no, null. Then you will consider it as a null hypothesis. Okay, so whatever the assumptions we have to make, we should put them in terms of hypothesis and especially in terms of null hypothesis. Now what test you will go for? Now this is assumption. You are already having data with you. So what test you will go for? Now that is the thing. you should consider whether it is a one sample, whether it is two dependent sample, whether it is two dependent sample. So obviously I'm comparing all the responses. I have not made any group in that. I'm considering age of all the respondents and I'm calculating mean of it and I'm comparing it with some hypothesized value. So I have considered a single sample. I have not made any groups. Suppose if I want to compare average age of satisfied employee and average age of dissatisfied, I'm not comparing it with any standard value, 55. I'm just comparing average age of satisfied, average age of dis. So that is two independent. So now which test is applicable for this one sample? So answer is t-test. Okay, so this is very important. Now when you are going to test your hypothesis, what variables are involved in that? How many groups you can create in those variables depending upon that? One sample, two dependent, two independent, k dependent, k independent, that is going to be decided and based on that t-test. But yes, remember another thing, there will be certain assumptions as well. So first assumption should be normally distributed. Population should be normally distributed. And samples drawn from the population should be random. So what techniques you should go for? Random sampling. That's why earlier I have told you that data analysis is interrelated with all the earlier phases. Remember, it is related with what objectives you have set. It is related with what hypothesis you have set. It is related with what sample techniques you have used. So suppose my sample is not random sampling, then I cannot go for the t-test. So I should find some other alternative. And remember one thing, for every parametric test, there is an alternative non-parametric test. So I cannot go for t-test. What next? So obviously the answer is go for non-parametric. The data measurement is data interval. It should be the scale of interval ratio. Mean now the scale of variable is also going to important. And scale, as I have discussed earlier, it depends how you frame your questionnaire. So suppose for age, if I have given the options like below 50, 50 to 60, 60 to 70, for example, more than 70, then I cannot consider my data as an interval ratio scale. It will be of ordinal scale. So try to understand that things are interrelated with each other. We cannot study them individually. Ultimately, all the earlier stages, all the earlier steps in your research process, they are going to have huge impact on your data analysis. So if all the assumptions are proved, then obviously we should go for t-test. Now another important aspect, what is meant by normally distributed? So my population should be normally distributed. Every time we cannot calculate our population, we don't know our population. So that's why it is said we have to assume certain things. So consider our population is normally distributed. All the 10 lakh employees, when I will collect the age from that, weight from that, the histogram will be like this. Means maximum responses, they are very near to the mean. And rest of the observations, rest of the responses, they are equally distributed both at left side and right side. So some observations, they are having value more than mean. Some observations, they are having value less than mean. But symmetry should be there. When such thing is there, we can say yes, our data is normally distributed. So every time there is no need to collect the data and go for histogram, because basically we are assuming that particular thing. And even if you want to prove whether your data is normally distributed or not, there are other techniques also, skewness, kurtosis, likewise. So based on that, we can identify whether it is normally distributed or not. But it is very important, because by assuming that our data is normally distributed, we are going for t-test. We are going to compare our sample mean with population. So what is the difference? and then divide the difference with standard deviation of sample. So now you come to know that why descriptive analysis. So in this particular t-test, we should know mean, we should know standard deviation, which is a part of descriptive analysis. And that's why I have said descriptive analysis is a base of inferential analysis. Suppose this is one population data, 20 observations, and these are 5 random samples drawn for that. That means I have selected 4, 7, 10, 15, 19th observations randomly from this population. And I will compare whether the mean population is equal to sample mean. Whether 28.75 is exactly equals to 29.4. Now mathematically, what is the answer? 28.75 is nowhere equal to 29.4. But what is mathematically insignificant, it can be statistically significant. So as you have not collected data from whole population, you have collected your data from sample, and then you are going to compare your results with population, that is inference. So some margin for error should be given over there. We should not expect exact value. Yes, there can be some difference between our sample value and population value, but the difference should not go beyond limit. It should be within certain limit. So here, after calculating, my value is 0.18. Now what is that limit? What maximum limit I can have? What could be that maximum difference which is acceptable? So now here, remember one thing, the population size was 20. You have drawn some 5 samples out of that. So how many combinations can be there? So you have gone for 4, 7, 9, 10, 15. What is other combination? 1, 2, 9, 8. So how many possible combinations will be there? So if you know permutation and combination, the answer is 15,504. So while selecting only 5 samples from 20, you can have 15,504 combinations. And now we have considered that we have drawn the sample from normally distributed populations. All these 15,504 samples, their value, mean value will be normally distributed. So certainly some samples will be there of which the mean is exactly 28.75. Some samples will have their mean which is somewhat greater than 28.75. Some samples will have their means less than this 28.75. And when we will go for this normal distribution of sample mean, we will find that 95% samples falls in accepted regions, while 5% will fall in rejection. So from 28.75 at right side, up to what level you can go? Up to what difference you can go? At left side, up to what difference you can go? So you have to decide significance level. So here, most of the time in standard research, the standard significance level is 5%, means we are going to reject 5% samples. We are going to consider them in a rejection area. So if your significance level is 10%, then what it indicates, you are going to reject 10% samples. Now, here the significance level is 5%, and I have shown 2.5% at left side, 2.5% at right side, because some samples they will be having mean less than, some samples they will be having mean greater than. So your sample that is going to fall in that particular region or in this region. Remember, assumption we are making it before data collection. So your sample mean can be in less area, greater area. So this is two-tailed. Now what is meant by one-tailed? Either from left region or right region. So again, another important aspects in data analysis, whether you are going for one tail test or whether you are going for two tail test. Okay, so here we will consider that our sample can be in any region. Maybe its mean will be less, maybe its mean will be greater. So what hypothesis we have put? Not equal to. Okay, means it can be less, it can be greater. So what other alternative hypothesis can be there? Mu should be greater than x bar. It is not equal, means we want it should be greater than right area. It should be less, so left area. So one tail, two tail, that is another important aspect we should understand. So now as we are going for two tail, we will divide our 5% at left side as well as right side. So 2.5% samples. Now percentage in terms of 15,500 So I simply put, suppose 100 samples are there, 100 combinations were there. So out of 100 samples, my 95 samples will be in accepted region, 5% will fall, or 5 samples will fall in rejection, 2.5 samples will go at this side, 2.5 samples will go at this side. So now whatever the sample you have selected, now this graph is for all combinations. And we are going to choose only one combination. Our sample is one of the samples in this particular graph. So what is the possibility that it will in this region, it will be in this region, it will be in this region. So we know 5 samples are in rejection area. So what is the probability that your sample is from that particular region? 5 divided by 100, 0.05, which we consider as a p-value. Probability, p-value. So to understand that basic concepts, we must know this normal distribution of sample mean. And when this is applicable, when we are drawing our sample from normally distributed population, then and only then this thing can happen. Whatever all possible combinations of your samples, 95%. Why 95? Because I have considered 5%. When I will consider it as a 10%, the statement will be 90% samples will be in accepted, 10% will be in rejection. So again, depending upon two-tailed, one-tailed, you should distribute it like that. So this is my difference. 0.18 is my difference. So in what region? What is the maximum limit I can have? So if we consider this as an error, what maximum error we can go with? So when these 5% samples, 2.5% samples will start, what will be the difference between them? Because these samples will have some less error. When I will start traveling at this side, my difference is going to be larger. And at this side, my rejection area starts. So what is the limit over here? What maximum error I can find over here? So if my value goes beyond that, I will straight away reject it. So how to find this? So every test is having its own table. This is a table for t-test. Now if you are having a one-tailed, you should go for this column, 0.05. If you are having two-tailed test, 2.5% at left, 2.5% at right, then you should go for 0.025. So 2.5% means 2.5 divided by 100, that value. And now what is this degree of freedom? Another important terminology, degree of freedom. So my sample size is 5 and I have considered degree of freedom 4. So number of samples minus 1. So why I'm skipping that one sample? So I know I want to compare whether the average age of my respondents is 55. I started collecting data from first respondent. He have given the answer. The respondents has given the answer 60. Next person has given the answer 58. Third has given 56. Fourth has given 54. Now I can calculate average age of these 4 respondents and I can manipulate fifth response so that the total average will be exactly equals to 55. Because every time the researcher thinks that if our sample mean is exactly equals to the population mean, our data is most reliable, is most adequate, is most suitable. And there are chances that the data you can manipulate it. So after getting four observations, after calculating the average of them, I can manipulate my fifth observation. I can set the value so that the average of 5 observations will be exactly equals to 55. That's why this degree of freedom is there. And degree of freedom is 5 minus 1, 4. So your calculated value is 0.18. Difference. Now what is acceptable? So acceptable is 2.776. This is the maximum limit you can go for, both at left side as well as at right side, because we are considering two TED. And now as my calculated value 0.18 is less than this critical value. So what is this critical value? Critical value is the value which I got from table. And remember, this value you should select based upon your significance level. 1 tail, 2 tail, and then degree of freedom. So this is critical value. This is calculated value. And why? What p-test suggests, if your calculated value is less than critical value, you should accept the null hypothesis. Means your population mean and sample mean exactly same, though 29 point something is not exactly equals to 28.75. Mathematically they are not significant, but remember statistically they are significant. We have carried out our research based on sample, so some margin for error should always be there. What is the maximum margin? We can get it from table. What is calculated? We can have that t-test. Now, unless and until you know this formula, unless and until you calculate it on paper, the test, if you apply it on SPSS, will directly give you the result. And sometimes the results are in terms of p-values. So 0.05 is our p-value. So if calculated p-value is greater than that, I will accept the thing. If my p-value is 0.04, means it is in rejected area. Anything less than 5%, any p-value less than 5%, you should straight away reject it. Means hypothesis you can accept or reject based upon calculated value, critical value, or based on p-value. So sometime Excel will provide you all these things. Excel will provide you critical value, calculated value, plus p-value. But most of the time SPSS, it will provide you the p-values. And the only statement you should remember, if your p-value is less than 0.05, straight away you have to reject it. So this is just one simple example. So whatever the test we are going to select, how we should go for it. So what data we want to test, whether it is one sample, two dependent sample, two independent sample, then what is the scale of that variable, how we have selected the sample, and based on that you should go for the test. So this is just one example, and while giving this particular example I have tried to show you what is the significance level, what is actually its significance with this normal distribution of sample mean. Why 5%, 10%? Okay, so as I have decided to go for whether the mean of my sample is mean of population, means 55. I decided to compare it with 55. Now what is my calculated mean? 55.7. What is population mean? What I have assumed, it should be 55. So whether both are same, so I will calculate using t-test. My error is, or my t-value, calculated value is 0.025. So what is critical value? So again two-tailed, by considering my sample can be in left area, right area, I will go for 0.025. Now 20 observations are there, so my degree of freedom is 19. So maximum limit is 2.093. So as calculated value is less than critical value, table value, I will accept my hypothesis. Though 55 is not exactly equals to 55.7, but statistically it is accepted. Okay, and then as I explained or as I've shown you some other assumptions, based on this data, is there any significant relationship between level of satisfaction and post? There is a significant relationship between level of post and satisfaction. Whether there is a fact that the employees who got retired from executive post, they are more satisfied than other people because of the highest package they are getting. So clerical, managerial, they are not satisfied, but only executive people are satisfied. I just want to check that particular relationship. Now again, for what test I should do? How you will now check the test or how you will go for the test? By considering the scale of your variable, whether it is related with one sample, whether it is related with two dependent sample, whether it is related with k dependent, k independent, two independent samples, we will go for the test. And now if you consider all these facts, the best answer is chi-square test, because post and satisfaction, they are nominal in nature. Here you are comparing two variables of nominal scale. So the best test is chi-square test. So when you are going to apply these tests, when you are going to study this test, one basic thing you should remember: applicability. Try to identify the applicability. Applicability, it is based on how you have drawn your sample, whatever the variable you have considered, how many groups you can identify into that, plus what is the scale of your variable. Based on that, you should go for it. So obviously chi-square test, it identifies the difference between observed frequencies and expected frequencies. For that, you should able to calculate expected frequencies with the formula. So here I will not teach how to calculate the things, but expected frequencies are calculated based on row total multiplied by column total. Yes, actually the collected data was different. Then you have to tabulate it like this. So out of clerical, 6 clerical employees, 1 is not satisfied, 5 are satisfied. Out of 7 executive employees, 5 are not satisfied, 2 are satisfied. Same in managerial, 3 are not satisfied, 4 are satisfied. So whether this is showing something significant relationship between the post and satisfaction. So these are observed frequencies. We have to calculate expected frequencies with the formula row total multiplied by column total divided by grand total. So now these are my observed frequencies. These are my expected frequencies. So expected frequencies means equal distribution should be there. Means executives, they should not be at any one side. All at no or all at yes. Somewhat equal distribution of all the employees should be there. So that's why expected frequencies in other manner. Then by calculating O minus E bracket square divided by E, and by taking some, now the calculated values there. So remember, calculation is not important. I'm not teaching you how to calculate the thing. I'm only teaching you how you are going to apply applicability of that particular test. And again, chi-square is having a value. Now here the degree of freedom is somewhat different. Look at this particular table. The data now you have arranged it in 2 rows and 3 columns. Now here the degree of freedom should be row minus 1 multiplied by column minus 1. Significant level, it is 5%. Degree of freedom, it is row minus 1 multiplied by column minus 1. So 2. So I will check this value in table. So now this is calculated value and this is critical value. So as calculated value is less than critical value, I will accept null hypothesis. So I wanted to check whether there is significant relationship between level of post and satisfaction for VRS. This was my basic assumption. This is my alternate. What should be the null? When the words like this, no. So there is no significant relationship between sorry, level of post and satisfaction of VRs. So I will accept this statement. So now chi-square is a test based on the variables of nominal scale. When two variables you are going to compare. There is another test like F test. It will compare the variance of two groups. So two independent samples. Earlier I compared mean age of two groups. So now here I am comparing variance. So some tests they will require mean, some tests they will require median, some tests they will require mode for comparison. Let's say for example variance. So now this is the thing. So how you should calculate the F value? Again you have to calculate certain things. Again you should compare it with table, and then you should accept or reject your hypothesis. So here my hypothesis was whether variance of age of satisfied employee and not satisfied employee is same or not. So which test I should go for? What scale of variable is? Whether I am having two dependent sample, two independent sample. Based on that, I should go for this particular test. That's why this chart is very important, which I have shown you earlier. In inferential analysis, these are the different tests. Which test is applicable for me? It is very important. Okay, so more than 30 tests are there. And then whatever the test you have decided to go, you should practice it on paper. You should try to calculate the results. And then obviously you can go for the ready-made tools. Okay, so F test is there. Now, I have compared variance of two groups. Suppose I want to compare the variance in terms of these three groups. Means the average age of this clerks, average age of this executive, average age of this manager. I can compare two averages. But now here I'm going to compare three averages: average of clerical post, average of executive, average of managers. Obviously average of age. So which test I should go for? So if two groups are there, you should go for T test, two independent. But now as three groups are there, you should go for ANOVA like tests. So here I have calculated ANOVA through Excel. So after going in Excel, so no paperwork is required over here. But yes, of course, you should know how to calculate ANOVA on paper. Then you just go for ready-made tools. So this is the answer in Excel. What significance level I have selected? 0.0. Yes, another thing, significance level is called as a alpha. So it is 0.05. You can change your. This is the result. As I said earlier, Excel will give you table value, calculated value. Excel will give you critical value. Excel will also give you p value. Now, as your calculated value is less than critical value, you will accept that yes, mean of all three groups is same. Even your p value, it is greater than 0.05. That's why also you can say, yes, averages are same. There is no difference. Remember alternate hypothesis. And the same test, I have applied it through SPSS. Remember one thing, before you are going to tabulate your data in SPSS, you should declare all your variables. There are two sections, variable and data. And here you should properly mention the scale of your variables. Because whatever the significance we have considered between the scale of variable and test we are going to apply, so your variable should be put in proper scale over here. And based on that, SPSS will decide the applicability. If SPSS finds suitable variables for test, then it will perform it. Otherwise, you cannot go for that particular test. So first I have declared variables, then I have tabulated my data, then I have gone for ANOVA. So average age I want to compare between all the categories of post, executive, managerial, and clerical. Okay, so same answer I got, but SPSS will only give me calculated F value. and it will give me this p value. So based on p value, I will accept this particular hypothesis. So what is important? So what objectives you have set, what hypothesis you have set, based on that, what data you are actually required, how you are going to collect that data, whether you are relying on primary source or secondary source. Though you are relying on primary source, then what is your sample size, how you have drawn sample. Then after preparing a questionnaire, after preparing the data, just tabulate that data. And when you are going for inferential analysis, what variables you are going to use in that inferential analysis, you should have descriptive analysis related with them. So in F test, I want to compare variance. So I should know how to calculate variance. In T test, how should calculate mean? How we should calculate standard deviation. Okay, so here I would like to summarize like this. So when you are going for data analysis, what are the essential things? Now we come to know that data analysis is related with all the pages. All the pages, they are going to have an impact on the data analysis. So try to identify a problem. So you can prepare one simple example where you can identify problem, you can set some objectives for that, you can set some hypothesis in that, then just identify variables in your data. Now when you are identifying variables, means you should identify their scale. Identify what sampling technique you are going to use, because some tests they assume that you have drawn sample randomly. What should be your sample size? Then actually collect that data. Identify that data characteristics. Means in sample, whether I can have one sample, two dependent samples, two independent samples. Obviously, they are based upon what hypothesis you have set. Okay, and then identify appropriate technique, whether to go for parametric, whether to go for non-parametric, and then just try to apply that technique, just try to calculate the things on paper, and then try to go for some ready-made tools. So I have not covered all the tests, and that is not the part of this particular workshop. Only thing is applicability. The only thing we should understand that the phases which we are going to have in our research process, if we carry those particular processes carefully, then definitely we can get a good quality of data. Definitely our data analysis will be also of a good quality, and the results which we have drawn from that particular data analysis will prove the quality of our data. So this particular figure we should always keep in our mind. So reliable data, adequate data, suitable data, it is depending upon the objectives, hypothesis, sample size, source. And these things we actually take care in our earlier stage. So with this, I would like to conclude my session. Once again, I'm very much thankful to organizers for giving me this opportunity to share my views. And I earlier, as I said, this is just experience, what I have gone through while carrying out my research, how I decided the applicability of my research. And especially again, I'm very much thankful to Dr. M.M. Ali sir for providing me this opportunity. And whether I could satisfy all you participants or not, just give the positive feedback. If you are having any questions, you can ask.
Thank you very much. Informative. I request all the participants, whoever is interested to pose any questions to Satikar sir, kindly post it in the comment box.
And as obviously Dr. Ali sir is also with me.
Yeah.
So
Any questions regarding to the basics of the research? Okay.
the only thing is important, that applicability of tests. So many tests are there. If you go and study each and every test, it is a confusing. So whatever the data you have collected, whatever the objectives you have set, whatever the hypothesis you have set, then you have to select the best appropriate test. Yes, of course, again considering one sample, two sample, dependent, independent, all those things. And on the data analysis part, it is obviously related with the basics of research. Though you are not in a phase of data analysis, but now you should remember that the phase in which you are. Let it be problem identification, let it be of setting objectives, let it be hypothesis setting, sampling technique. Now just try to understand that they are going to have huge impact on the tools which you are going to set or select in later stages.
Yes, sir. It's vital in research because it makes studying data a lot simpler and more accurate. So I
Yes.
feel that it's definitely more useful to all the interested researchers. Sir, if possible, will you please share your PowerPoint presentation with us so that we can forward it to our participants?
No problem.
Yeah,
No
anybody
problem.
who
No
is
problem.
interested, yeah, ask them to
Thank you
be
very much,
there.
sir.
I will mail it to concerned organizer so that he
Yes, sir.
can get it and yes.
Okay, thank you very much,
If the,
sir.
if the participants are asking for any one of us numbers,
Yes,
okay,
sir.
or
Yes, sir.
email ID, you please share with them. No harm.
Sure, sir. Sure.
Because,
Definitely, sir.
because yesterday
Yes.
there was a question from Punjab University, some from Punjab University, if I'm not wrong.
Yeah, yeah.
The
Yes.
one lady asked a question and she was interested in my
Email ID.
email ID. So
Yes, sir.
please, if any participants ask about both of us, a number or email ID, please share with them.
Definitely, sir. Definitely.
Thank you.
So yeah, I feel there are no questions, sir, because the comment box is blank.
No problem.
And I what I feel is your explanation was so simple and so lucid and so informative that probably everyone must have understood it very clearly. Thank you very much, sir.
Yes, yes.
And
So I am
for
optimistic
the
also.
yes, sir. So thank you very much, sir. Thank you, Dr. Ali, sir, for introducing such eminent, such expert statistician to us and to highlight some of the what I can say is, Sir has developed in-house software that is very remarkable on his side, and not everyone of the statistician or any person can do it. So, congrats to you, sir, and I
Thank
thank
you.
both Dr. Ali, sir, and Satikar, sir, on behalf of the organizing committee on behalf of Anjuman Degree College, for giving us vital information on understanding of basic research and research methodology. Thank you very much, sir.
Okay,
Thank you.
thank you.
Thank you.
Next.
Suleiman? Suleiman,
Yes, madam.
shall we
Yes, madam.
conclude? Shall we
Yeah, madam.
conclude?
Yes,
Okay.
yes. Yes.
So tomorrow we shall meet at the same time, 12 o'clock.
Same time.
If you, yeah, if any of the participants have any queries, you can post it in the WhatsApp chat box. Thank you. Have a good day.